Okay, here in this video, I'm going to talk about the hypothesis testing like this. Uh, okay, so let me start from what we have, right? So we are only interested in beta and gamma, but I will just assume that theta includes alpha, but it doesn't need be. If you used demeaned variables, you can just ignore the intercept. And also, we calculated the asymptotic variance, right? Asymptotic variance from the GMM was calculated, and it'll be like 3 by 3 matrix. V11, V22, V33, and V12, V13, V23, and it'll be symmetric. So it will help later. So we just have these two, and asymptotic results will be stated in this way. Your GMM estimator minus the truth will be going to normal 0V. Okay, so this is your like asymptotic result that we derived in the previous questions. Okay, this means I will rewrite this as, so usually in undergrad class I approximate this as GMM minus GMM is approximately normal distribution with theta 0 time comma V over N, right? Basically this is approximation, right? Theta hat can be written this way, like so. Square root to n is divided here, and it goes like theta 0 is moved to the other side, then you get this. And then now we are interested in that this is 3 by 1 and this is 3 by 1, it is 3 by 3 variance matrix. And here we are interested only in beta plus gamma. So beta plus gamma can be written as 0, 1, 1 times alpha, beta, gamma. Okay, it is matrix notation, like vector notation. So I am going to write this as r times theta. So r times, or you may put like transposition there, where r is 0, 1, 1. Okay, then that means using this notation, what we have is from here, r times theta hat GMM is approximately normal r transpose theta 0, comma 1 over n times r transpose VR. This is maybe what you have learned in undergraduate course. Basically, idea is the same, right? Or if you use this asymptotic approximation directly, you can just use the same thing. R transpose theta 0 converges in distribution to normal 0, R transpose VR. Okay, so we are going to use it, right? And then H0, which means H0 is this, which can be rewritten as R transpose theta 0, like beta 0 gamma 0, equals 1 or not. So then you can, and so put it this way. These asymptotic results true regardless of H0. So even if H0 is wrong, these are correct. But just we do not know where is the theta 0. Okay, so then from here we are going to divide two cases if H0 is correct and if H0 is not correct, right? If H0 is correct, then what we get is we assume R transpose theta 0 equals to 1, then from the earlier derivation we get R transpose theta hat minus 1 is approximately normal 0 R transpose VR. Okay, so that means then from here the quadratic form R transpose theta hat minus 1 n times R transpose VR inverse, matrix inverse, and then transpose here RT theta hat minus 1 follows chi-square rank. Its rank, which is 1. Okay, converging in distribution. So maybe I should have reminded you this. So remember, if a random variable x converges in distribution, normal distribution like 0v, then x transpose v inverse x converges in distribution to chi-square rank of v. Okay, so this was definition of chi-square, right? When you have normal distribution, then it's weighted, variance inverse weighted quadratic form is chi-square. That is the definition. Then back here, then what we need to check here is the degree of freedom. The degrees of freedom should be 1 because it is basically 1 by 1. R is 3 by 1, but after transposition is 1 by 3, 3 by 1, and 1 by 1. And so the variance is 1 by 1. As long as this variance is not 0, the rank is 1. So this is null distribution. So when your hypothesis is true, it will go to somewhere else. But if it is not, then R transposition theta hat minus 1 transpose the variance R transpose theta hat minus 1. This guy is not converging to chi-square. Instead it will go to so this guy will so 1 is wrong, but this will go to chi-square 1, right? However, when you use minus 1, you will have additional term like this, right? And this term is not 0, so after multiplying to n, this term will go to infinity. So if not 0, so that is, it is wild test. That means the test statistic T or W, usually in textbooks it is called W. W is defined as R transpose theta hat and minus 1 transpose R transpose VR inverse and R transpose theta hat and minus 1 is the test statistic, and its null distribution is chi-square 1 under the null hypothesis and infinity under H1 under the alternative hypothesis, and the critical value is the 1 minus alpha quantile of chi-square 1. That is, chi-square distribution will look like this, and we are going to set a critical value here so that this area is alpha, and we will reject H0 if Wn is greater than C. Okay, So that means Wn should be close to 0 on if H0 is true, but it will be very big if H0 was wrong. So we are going to reject if it's too big, okay? So, and then how do we set the threshold? That depends on the significance level alpha, okay? Then choose the critical value accordingly. On the other hand, by the way, if it was too hard, there was actually a simpler way, z-test or t-test, that you learned in the undergraduate course. So because it works like earlier, I said R transpose theta hat n, which is basically this, right? This approximately follows normal distribution 0 v over n, v R transpose R, right? So then that means like let's simply call this sigma squared, okay? So that means you can use a test statistic like this, sigma hat. And then because it is normally distributed, and then you will reject if this, so like say under the null hypothesis, if r theta 0 was 1, it will be close to 0 if H0 is correct, but it will be different from 0 if H0 is wrong. So you are going to reject if it's too small or too large, too much different from 0, right? And it will be usually like minus 1.96 or plus 1.96 when alpha is 5%. This is the z-test, okay? You could use this because it is one-dimensional test. When Q is 1, when you are testing only one hypothesis, single hypothesis, then you do not need to use the squared, because in one dimension the distance is very natural to estimate, but if Q is greater than 2 or large, then you have to use chi-square, right? And like actually this z-test is a kind of chi-square test. If you square it, that will be chi-square test, okay? So they are connected. I had to tell you in this in class. I could not have time to do that. Okay, this is all, and I will review your answer. I'm not sure if it helps or not. So if you have questions, you are very welcome to see me as questions, or if you wanted to see your answers,